Welcome to the Futurist Society podcast, where we delve into the latest advancements in technology, science, and culture. From discussions on the latest breakthroughs in AI, biotechnology, and space exploration, the Futurist Society is your window into all of the awesomeness that the future holds. Get ready to be informed and inspired as we consider the positive impact of emerging technologies on humanity. Without further ado, welcome your host, Dr. Awesome.
Hi, everybody. Welcome back to the Futurist Society. Today, we have a really special guest. His name is Dr. Avi Loeb, who is very familiar to me and also probably very familiar to you. And as always, we're going to be talking in the present, but talking about the future. So Dr. Loeb is the really esteemed professor at Harvard University. He's actually the Frank Bird Professor at Harvard University. He's also the director of the Institute for Theory and Computational Learning and the head of the Galileo Project, which I'm really excited to talk about. But, I wanted to start out and just zoom out. So you're an astrophysicist, you're a physicist, you look at the stars, and you're seeing the future happen because a lot of the stuff that is really in the news today is about space. It's about the stars. It's about interstellar life and extra things that we probably didn't think about maybe 20, 30 years ago. And so it's a really exciting time, I think, to be in your field. So tell me, just in a nutshell, right now, what you're doing with the interstellar component of it, because there's so much to talk about. I want to talk about like the space component and, humans going into the stars. But the interstellar component is when I first met you, is when in 2017, we saw this I guess some people are calling it an asteroid. You have different thoughts about this asteroid that came into the solar system called Oumuamua. And it was a really exciting time to be in science because it was unlike anything that we had ever seen before. So let's just focus on the interstellar component for a second, because I think that's the most interesting thing about what you're doing right now, even though you're doing a ton of interesting stuff. But the interstellar component has Oumuamua as something that I wanted you to briefly comment on, but then eventually we're going to get into your current research, which is some of the stuff that you found in the ocean, which is really interesting. So let's start with Oumuamua. It was this totally different thing that had come into our solar system, and everyone else was saying that it's just an asteroid. It has all of these other things that it could be, all these other characteristics that it could be, but you thought differently. Can you tell me a little bit more about that?
Yeah, so what I find is that common sense is not common. And let me just start with the big picture first. The human species came to Earth just a few million years ago, and that's 1 part in 10,000 of the age of the universe, 13.8 billion years. And we also know that we are not at the center, the physical center of the universe. Nicolaus Copernicus figured it out. In fact, a few weeks ago, I visited his hometown, the place where he was born. I was invited by the Polish government to celebrate 550 years to his birth, and I gave the keynote speech about the next Copernican revolution, which is about whether we are at the intellectual center of the universe. A lot of people still think that we are the only intelligent species that ever appeared in the universe. And I don't think so. It's just, when you look at the sky at night, there are hundreds of billions of stars in the Milky Way galaxy alone. It's very arrogant to think that we are unique and special, because we know that a substantial fraction of them has a planet like the Earth, roughly at the same separation as the Earth is from the sun. And we just need to look instead of have an opinion. If I just look out, I see neighbors next to me. But if I were to stand at home and say, where is everybody, like Enrico Fermi said about 70 years ago, I would not find a partner this way. We all know that not only you need to look out, but you also need to go to dating sites to find the partners. And the other thing, is that, besides the fact that we are not at the center of stage, we arrived late to the play, the cosmic play. So a simple conclusion is that the play is not about us.
Mm-hmm.
And if you arrive at the end of the plane, you're not at the center of stage. That's an obvious conclusion. And my point is, in the past, we were waiting for electromagnetic signals of light. And the problem with them is they propagated the speed of light.
Mm-hmm.
So it's just like waiting for a phone call at home. If you're not at the right time listening, you might not hear any ringing. And those signals that were transmitted 1 million years ago are now 1 million light years away. But there is a better way, and that is to search for objects that may have arrived to our backyard from our neighbors. If you look around at your backyard, you might find a tennis ball that was thrown by a neighbor, and you might decide, okay, now I not only know that I have a neighbor, but the neighbor also plays tennis. That's an important realization. And I'm sure that if we do find the equivalent of that, there would be conferences attended by scientists who will write plenty of papers about whether the neighbor plays tennis or not. So that is my goal, to look around for objects, because objects that we launched into space, all the spacecraft that we launched, are moving 10 times slower than the escape speed from the Milky Way galaxy. And so they're still around. They accumulate over time, over billions of years, like plastics in the ocean. And for example, Elon Musk, he needed a dummy payload to the Falcon Heavy launch of 2018, and he launched his car, the Tesla Roadster, and it's now in an elliptic orbit around the sun. And I don't believe that Elon Musk is the most successful space entrepreneur over the past 13.8 billion years, and there could be a lot of space trash out there. We just need to look. If astronomers were to search for the Tesla Roadster, they would not find it, because we can only see with our best telescope right now objects that are bigger than a football field. And we looked out for the first time in history with the telescope in Hawaii, just monitoring objects bigger than a football field, bigger than 140 meters, to protect Earth. The idea was they pose a risk, and so any near Earth object should be tagged. And so they found a near-Earth object and realized back in October 2017 that it's moving very fast. In fact, it's not bound by gravity to the sun. It was given the name Oumuamua because it was the first interstellar object, an object that came from outside the solar system. We know it because it was moving too fast relative to objects that are bound by gravity to the sun. And it was anomalous. As it was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. And that meant that it has an extreme geometry, most likely flat, based on the variation of light.
And most asteroids are not flat like this.
They're not the factor of 10 change in the reflection as they tumble. They're usually up to a factor of 3. And moreover, they're not flat, usually. And this object showed a push away from the sun by some mysterious force without any evaporation. There was no rocket effect from gas or dust coming off it, because we didn't see any cometary tail. And in fact, the Spitzer Space Telescope looked very deeply, couldn't find anything. So the question was, what's pushing it? And I simply made the conjecture that this is a thin membrane, perhaps a surface layer of a bigger object that was torn apart. But nature doesn't make very thin membranes, less than 1 millimeter in thickness. And I said, maybe it's technological in origin. And that by itself drew a lot of attention from the public, from my colleagues. The paper was accepted for publication within 3 days. But that drew me to this possibility that we should search our backyard for other objects. And we discovered with my student, Amir Siraj, about a year later, a meteor, basically an object that collided with Earth, roughly the size of a watermelon. It was discovered as a result of the light that it produced, the fireball that it generated as a result of its friction on air. It was discovered on January 8th, 2014, so almost 4 years before Oumuamua, by US government satellites that are monitoring Earth for ballistic missiles, any national security threats. And they saw this fireball and measured the speed of the object, and we calculated that it must have arrived from outside the solar system. And moreover, it was moving faster than 95% of the stars near the sun. And and it exploded in the lower atmosphere of the Earth, about 20 kilometers over the Pacific Ocean.
So the speed was atypical for asteroids, or was it pretty consistent with other asteroids?
The upper envelope.
Okay.
But that was the speed relative to Earth.
Gotcha.
And it came from behind the Earth as the Earth was orbiting the sun. So in fact, relative to the sun, it was the fastest.
Mm-hmm.
And it was way above the speed necessary to escape from the gravitational pull of the sun. And outside the solar system, it was moving at 60 kilometers per second, faster than 95% of the stars. That's a speed that is thousands of times higher than the speed limit in the highway. Okay. And moreover, the object exploded only in the lower atmosphere. And so that meant that it has material strength tougher than all other meteors recorded by NASA, 272 of them over the past decade. So to me, it raised the possibility that it's a Voyager-like meteor. Imagine our own spacecraft Voyager colliding with a planet like the Earth in the future. And it will appear as a meteor of unusual material strength and unusual speed. And that's what led me to suggest that we go there to the Pacific Ocean and collect materials from this meteor, because we could figure out at a cost of $1.5 million what this object was made of. To do that in space with Oumuamua or any future object looking like it would cost billions of dollars.
So a couple different things that I want to ask you about as someone who's not an astrophysicist. I think that the majority of the general public sees the rapid amount of new information that's coming that gives credence to we're not alone in the universe, right? It's not only Oumuamua, it's not only the stuff that you found from this asteroid, but also just the governmental inquiries, the unidentified aerial phenomenon, the UAPs or UFOs, as they used to be called. And I guess that I have two parts to this question. Number one, is it just because we haven't been looking the same way? And now that we have access to all of this new information, now we realize that there's a lot more anomalous stuff that's out there than we ever realized before? Or is it number two, that now there's like a consensus that you don't necessarily have to be on the fringes of the scientific community to go into this kind of research?
Well, both of these aspects come to fruition right now, because we couldn't detect objects like Oumuamua more than a decade ago. There wasn't a survey telescope that allowed us to do that. The telescope in Hawaii was constructed because the US Congress, tasked NASA to find all objects bigger than 140 meters that come close to Earth. They pose a risk. And so this was the reason that such a survey telescope was constructed. And the US government didn't employ a network of satellites of the quality that it has over the past decade. So we couldn't really find objects like that before. And so that is, of course, one part of the motivation to study interstellar objects. But the second is that we know that a significant fraction of the stars, maybe a quarter, have a planet the size of the Earth, roughly at the correct separation for those planets to have liquid water on their surface if they have an atmosphere. And the chemistry of life as we know it could take place there. So I think it's only reasonable to be curious, and we should not have an opinion. A lot of people have a strong opinion, but that's not the way science is done. New knowledge does not fall into our lap. We have to invest in the research, both funds and time and effort. And that's what I'm committed to. My day job is figure out what's beyond the solar system. The day job of government is national security. And the fact that they provide some assistance in identifying meteors or talking about unidentified anomalous phenomena, the way that the Director of National Intelligence did in 3 reports to the US Congress, helps science because it raises our wonder, our curiosity. For those people who are fundamentally curious, for those that have a strong opinion, it bothers them. With respect to the UAPs, the unidentified objects the government talks about, I decided to establish the Galileo project at Harvard University, we have an observatory that we assembled over the past 3 years. And it's now functioning, collecting data all the time from the entire sky. We have hundreds of thousands of objects that we monitored, and we're using machine learning software to figure out if there are birds, airplanes, balloons, drones, things that are familiar.
Mm-hmm.
And from a scientific perspective, even if 1 in a million came from outside of this Earth, that would be big news that will change the future of humanity.
Mm-hmm.
I hope for the better.
Yeah.
Just like finding a letter or a package in your mailbox, you realize someone sent it. From the point of view of the government, maybe it's sufficient. They established a new office called the All Domain Anomaly Resolution Office. And that office announced a few months ago that they identified 97% of the objects that were reported about by military personnel. And maybe for them, it's satisfactory to have 97% figured out. As I said, from a scientific point of view, we really are interested in the few percent that they cannot figure out.
Mm-hmm.
And we want to know if any of them is from outside of the solar system.
Yeah, no, I think that everybody wants to know that. I mean, I think it's at least from the younger generations that I talk to, it's one of the first things that they think about when they're thinking about future technology. And,
Right.
you know, it's rather than artificial intelligence or some of these other consumer items that might make their lives better. Everybody has this sense of wonder and excitement when it comes to
Right. I mean,
stuff.
Just a couple of days ago, I gave a public talk at Sanibel Island in Florida. And not only that the room was full of people, but half of the people were young. And
Mm-hmm.
it was the first event where so many young people showed up, according to the organizers. And there was a book signing event afterwards. And I asked the young people, why did you come here? And they said, we've been following you since Oumuamua. And
Mm-hmm.
apparently I have a large fan base. The other thing that happened to me over the past month, I was invited to the Munich Security Conference. And it's the first time that the organizers decided to invite a scientist for a major Q&A forum. And I spoke for 45 minutes. And before that, we just went to the roof to have a drink. And on the roof, there were snipers with black head masks. And apparently they were there to protect Kamala Harris and Volodymyr Zelensky and other heads of states that were in the building.
Mm-hmm. And you too, right?
Well, no, so that's the main point that I wanted to bring up, that they were not there to protect me. So what I figured out from this is that talking about extraterrestrial life is less controversial than being a politician.
Yeah. Absolutely. No,
because nobody wants to kill me, you see.
Yeah, no, I see. I think it depends, because controversy comes in different forms, right? And like, you know, some of the controversy that has come up relatively recently and the research that you're publishing is just like the different potential outcomes that your research could come from other than something that's interstellar, you know. And I do want to touch on that, because some of the things that I've noticed, and again, I'm not an astrophysicist, I'm a layperson when it comes to this kind of stuff, is just, I feel like, and correct me if I'm wrong, I'd love to hear your thoughts on this, but I feel like it's like they're grasping for things that are just much more intangible than just accepting the data as it is.
Well, so I get a lot of pushback from within academia, and the reason is simple. It has nothing to do with the subjects that I'm talking about. It has to do with the public attention.
Mm-hmm.
And the reason I say that is because at first, when I started considering the extraterrestrial origin of Oumuamua and so forth, there was a lot of people supporting it within academia. The paper was accepted within a few days, and I got a lot of emails supporting it. The referee said, in fact, it looks like the object is flat, so your conjecture makes sense. The hate messages started coming in when the public became fascinated. And it got to a point where, I had a number of high-level profiles over the past few months in major magazines and newspapers. And that led to some people to make nasty remarks. just because the public cares about what I'm doing. And to me, it makes zero sense. To my daughter, it does make sense because she says that whenever singers get to a certain level of fame, they always have haters.
Absolutely.
And I'm not familiar with that because I was always doing science and I did it the same way throughout. It's just that this subject gets a lot of attention and that bothers some of the critics that I had. But two things on that. One, I developed the approach of the eagle. You know, the eagle very often has crows riding on its back and pecking at its neck. And instead of fighting them off, the eagle just rises to greater heights where the oxygen level is too low for the crows to survive, so they drop off. And for me, that's equivalent to rising to the greatest heights of scientific inquiry, analyzing materials, getting the results out, and doing the scientific work to the best of my ability. My hope is that there will be very low levels of oxygen from my critics at that point, and they will drop off. I don't want to mud wrestle because it gets me dirty if I do that.
Can we talk about some of the scientific controversy for just a second?
Right.
So, I know that the meteor that came in 2014 has been criticized as potentially at least the impact has been potentially been criticized as just like the sound that you would hear from like a truck, right?
Yes.
And that's something that I think a seismologist came out with.
Right.
And then also in regards to, for the people who are not familiar, Dr. Loeb found these little spherules, right? Which are, I'd love for you to
talk
hear
more about.
No, but like, I guess that there's some controversy about that, but let's just talk about the meteor itself.
Right.
And then this idea that it was coming from a truck or something like that.
So, I mean, this was reported very widely over the past week or so, but it has no substance. And let me explain. We based the localization of this meteor on what the NASA and the Jet Propulsion Lab put in the official catalog on a website for this meteor. There was a localization to within an 11-kilometer box, and it corresponds to about 1/10 of a degree in longitude and latitude. So the peak brightness of this fireball was localized there. And why is the peak brightness the most important point? Because that's where the explosion was the biggest, and that's where you expect to find the debris. Okay, so if you are searching the debris, you want to use the peak brightness of the meteor fireball as the location where you will start the search. And so that's the box that we used to design the expedition, to survey the ocean floor for the debris from this meteor.
Right.
It was based on light, and I repeat, light detected from the explosion by sensors aboard US government satellites. And then just before we went on the expedition to that box that we wanted to survey, we checked the data from a seismometer on Manus Island, about 85 kilometers away from the explosion site, to see if there is any signal that appears in that seismometer data from 2014 at the right time, with the time delay associated with the speed of sound. We all know about, a thunder appearing after the lightning, just because the speed of sound is slower than the speed of light. So we found a blip in that seismometer, and we said that's perfectly in agreement with the localization that the US government provided, also the altitude, because the altitude gives you additional delay, and we found it to be fully consistent. So we said, great, now we have an independent confirmation of the government data, but we did not choose the location based on the seismometer, because the seismometer, a single station, only gives you a distance, and that means you don't know in which direction to go. So it's a circle around the station. You could survey the circle, but that's a huge region. So we did not base our survey on that seismometer. We based it on the government sensors that detected the light. So now comes a group from Johns Hopkins, led by a scientist named Ben Fernando, who writes a preprint that was not refereed yet, just submitted for publication, and makes immediately a press release about it saying, oh, we found that seismometer signal could have been.
Yeah.
He doesn't know, but could have been a truck in a nearby road. Okay. And then he says, oh, they went to the wrong place. Why? Because if we use additional seismometers from other places and other sensors for infrasound, we actually get a very large ellipse of uncertainty. And I, of course, knew about it, and that's why we didn't use all that data to localize. So they get an ellipse which is hundreds of kilometers in size, and they say, oh, well, it could have been anywhere in that ellipse if we ignore the Department of Defense data from. So why would you ignore the data that discovered this meteor? They ignore it, and then they say the seismometers give a huge region, therefore the expedition went perhaps to the wrong place. And perhaps this seismic signal was actually a truck, perhaps, both of them perhaps. And by the way, this large ellipse of uncertainty overlaps with the Department of Defense uncertainty, so a much smaller box. And so any scientist knows that if you use a set of instruments to measure something, and then you have much poorer data with a bigger ellipse that includes the previous data, they are not in conflict.
Right.
You take the better data.
Yes. Yeah.
However, these people say, no, we don't believe the better data because it's the US government. It's the US Space Command. It's the US Department of Defense who used satellites, and they might be wrong. We use only the data publicly available from seismometers, and therefore the expedition could have been in the wrong place. And they go to the New York Times, they go to places and say, oh, they were misguided. It was a truck. It was not a meteor. Well, first of all, the existence of the meteor is known to all of us because of the US government sensors. So how can you, on the one hand, talk about the meteor and then say, oh, it could have been anywhere, but I don't want to use the best data I have to localize it? That's basically the foundation for their statement, which makes zero sense. I thought nobody would pay attention to this unrefereed preprint. But since all these newspapers reported about it, you know, I wrote a short research note where I explained what they did wrong in the sense that, for example, there was a flash when the meteor entered the atmosphere. There was a flash of the entry into the atmosphere. That was one location that the government reported about. Then there was a second location, which is the peak brightness of the meteor. They thought it should have been the same, and therefore they claim the government doesn't know what they're talking about because they changed the location. And this kind of statement, you know, that the government doesn't know what they're talking about just because the entry spot is different from the peak brightness spot is, you know, not professional. And for them to come out with a press release without checking actually is irresponsible, I would argue. Nevertheless, a lot of people that want to argue that we went to the wrong place jumped up and down. There was also a statement from a different group, all related to each other, because these are scientists that want to bring it down. They just see a flower rising above the grass level, they want to step on it. And so the second thing that was done was when we were analyzing the materials that we collected, those molten droplets from meteors.
I want to talk to you about this.
But while we were doing the analysis, there were people stating, oh, they just found coal ash.
Industrial pollution, right?
Coal ash. So they didn't have access to the materials. We were analyzing the materials, yet they had to make a statement before we come out with the full analysis. At the time that they came with this statement, we just looked at about a few percent of the molten droplets that we found. So, okay, that was very preliminary for us to just start with the analysis, and they immediately made a statement, oh, it's just coal ash. And so we went to the literature, looked at the elemental composition of coal ash and compared it to our materials. 55 elements from the periodic table showed very different abundances by orders of magnitude relative to coal ash. So it's not coal ash, okay? But the fundamental question is, why would scientists have the urge to make negative statements about an ongoing research project before the analysis is finished? And now that we have the full analysis out, they changed course and argue that we went to the wrong place. And it just shows you that there is a hidden motivation behind all of this, just to bring it up. And
do you think,
the thing that bothers me a lot is why is childlike bullying more prevalent than childlike curiosity? Okay, because that is very clear on social media, on which I have no footprint. But I would expect in the scientific community for people to be motivated by curiosity. We are all trying to figure out the truth. I wrote a paper just a month ago, and you don't hear about it. I wrote a paper explaining the results from the analysis of those molten droplets that we found. It talks about this explanation. They just want to argue that we didn't go to the right place, we didn't find the right thing. And before we went there, they said, you will not find anything. That also was a theme. Because we don't believe the US government. And this organization, the US Space Command, that issued a formal letter certifying at the 99.99% that the velocity measurement of this meteor indicates that it's interstellar in origin. That was certified in March 2022. It took them 3 years. They took time from their day job at the US Space Command. That's the organization that gets $30 billion from in funding, more than NASA, to alert the US president about any incoming threat, ballistic missiles. And these astronomers are claiming that the US Space Command, who issued this letter, does not know what they're talking about, that in fact, the velocity was 3 times lower. And this object came from the solar system. And that was done a year after the letter was issued. And I say to myself, why do they sleep well at night, knowing that there is an organization getting funded at $30 billion who issues documents, official documents to NASA, and when their taxpayers' money is being wasted according to them, and we are not protected from ballistic missiles. If they are wrong by a factor of 3 in a speed measurement, they would alert Mexico for a missile heading towards Washington, D.C. And all of these are scientists motivated by something else. And, the biggest force in academia is not electromagnetism. It's not the weak interaction. It's not gravity. It's not the strong interaction. It's jealousy. It's all about ego. And many people use academia as a sandbox to demonstrate their superiority intellectually relative to other people or relative to the public. That's the other thing I don't like. I was born on a farm. I feel that I'm not superior to anyone else in the public. And I communicate with the public and I listen to the public. If the public cares about this subject, I will put my time and energy to resolve it. However, it became fashionable in academia to distance yourself from the public. And that's a self-inflicted wound. That's why there is such a big separation between what's done in academia and what matters to people in society. And my view is that we need the course correction. It's just like for GPS systems. We need to recalculate academia.
I agree.
And it caused some turmoil at Harvard University in recent months. And the way I see it is that there was a bubble created within Harvard University, and it burst because of friction with the outside society.
Absolutely.
And that is an indication that academia needs to be recalculated.
So I have one foot in academia myself, and I wouldn't say it's jealousy. I feel like it's careerism, right? And making a name for yourself. I like to think that people are good people at the end of the day, and they're looking out for their own best interests, their family's interests, and stuff like that. But I think what you touch on is this idea that there is this counter narrative to what it is that you're proposing, right? And I'm trying not to be a conspiracy theorist because I want you to be right? Like, I know enough about my own biases that like I'm trying to distance myself from them because I want to be in a organization of planets where I can meet an alien and we can have, a meal together and learn all about what
as long as they don't eat people.
Exactly.
You see, because if you go to a restaurant right now.
Exactly.
We are eating animals that we regard as less intelligent than we are.
Right.
So we must leave a very good impression
Yeah.
in our first encounter with aliens.
Absolutely.
Because if they feel that we are not very intelligent, they would eat us.
Yeah, which is another thing I would love to talk to you about. I would love to talk about first impression, because I feel like you're going to be on the short list for the people that are going to be able to talk to them. And I'd love to talk to you about how that's going to go down. But my point is I think that there's this counter narrative, right? And every time you have, I wouldn't say incontrovertible evidence, because there has been no smoking gun that has appeared yet. It's all evidence that is based on science that is, it's not definitive. We haven't had an alien come in and shake our hands yet, right?
But if we don't search, we will not find anything.
Absolutely. No, I totally agree with you. But my point is that do you think that this counter narrative is something that is more than just a collection of self-interests, like the self-interest of the press to promote controversy, the self-interest of these professors to get their name out there instead of your name out there?
I do think so. Yeah, I think it's human psychology. And I think in this case, I find it problematic because this is the most important scientific question that we can answer. Because if we are not alone, if there is a higher intelligence out there, we can learn from it. Just looking out at my neighbors, I learn from them when I look at what they're doing. If I were to converse with them, then I would learn something new. And it's an opportunity for us to change our priorities.
Absolutely.
Right now, we are engaged in zero-sum games, in wars, conflicts, killing other people, which makes zero sense. That's the least intelligent thing that you can do. Cooperate, we live for such a short time. Why not cooperate and work together for the prosperity of everyone? And so perhaps, seeing a neighbor that did better than us will inspire us to do better and work together. At the very least, it will convince us that we are all part of the same team because there is someone else out there.
Absolutely.
And so I think it will be revolutionary. It would be more important than the first Copernican revolution for us to find that there is someone else. And it doesn't need to be someone that is in existence right now. That may have been another culture that existed 1 billion years ago. And we can learn from it because their technologies are likely to be far more superior than ours. They reached our doorstep before we reached their doorstep. And so that's why it matters to me. Okay. And if the US government has some materials or information that they found, I would love to know about it because it would save me decades of research of my own time. But I'm not waiting for the government to tell me what's out in the sky because the sky is not classified. The oceans are not classified. So we can search ourselves. And most people just have an opinion and they say, we didn't see anyone, we didn't encounter anything. But the same is true about the Higgs boson. If you were just to say, I haven't seen the Higgs boson and be done with it, that would not be satisfactory, scientifically speaking. You have to invest $10 billion in the Large Hadron Collider for that machine to discover the Higgs boson. Space is huge. Time is huge relative to the scales that we're familiar with. And, we should invest in the search before saying anything. We only see reflection of sunlight from objects bigger than a football field. We don't know how many smaller objects are floating near Earth. And so, we should stay humble and curious and do the search. And instead, what I see is that even as I do the search, people who are not doing the search are ridiculing it. Why would that be the case? Let's all be curious. And, we went to the Pacific Ocean, to the site of this meteor. We found with a magnetic sled that collected magnetic particles from the ocean floor that was 2 kilometers deep across a region that was 10 to 20 kilometers in size around the Department of Defense error box. We retrieved 850 spherules, molten droplets, less than a millimeter in size. And by now we analyzed all of them. And we found that about 10% of them, a tenth of them, are of a type that was never reported in the scientific literature before. They have a composition of elements from the periodic table that is very different from the material that made the solar system. Elements like beryllium, lanthanum, uranium are up to 1,000 times more abundant than in those materials that came to make the sun and the planets in the solar system. And the question is, where did they come from? And it's possible that it was a rock that was made from the crust of a planet very different than the Earth, the moon, Mars, and other moons and planets in the solar system. Because the most common star in the Milky Way galaxy is 10 times less in mass than the sun. So the sun is not a typical star. Most stars are dwarf stars. The nearest one is Proxima Centauri. It's the nearest star and the most common star, about 12% the mass of the sun. And I figured out in a recent paper that was accepted for publication last month in work that I did with my postdoc Morgan McLeod, that in fact, if you bring a planet like the Earth close to the most common star, it would rip it apart. It will spaghettify it, make a stream of rocks, half of which will be ejected to interstellar space at the kind of speeds that resemble this meteor. And the rock on the surface of the planet will be molten because of its proximity to the star, and you will differentiate some elements from others. And the elements that you would find most abundant would be those that we found. And so here is a potential explanation for this meteor that I published just last month. But even though it gives clarity to how such an object can arise naturally, it didn't get much press. We put a press release, no reporter wanted to report about it because it's astrophysics.
Do you think that, so even in the astrophysics community, you have people like Neil deGrasse Tyson that are on the opposite side of this argument. Do you feel like it's still a third rail and that this type of research is not it's not as valued as other research?
Well, first, let me say that Neil is not a practicing astrophysicist. He didn't publish a single scientific paper over the past decade.
Yeah.
Okay. So there is a difference between people who are popularizing science and those who are actually in the trenches.
Yeah.
Okay. It's the difference between a spectator looking at a soccer match and the players in the field. The spectator is not supposed to tell the players how to pass the ball, although very often they do.
Yeah.
And so, I'm one of the players. I'm still playing.
Yeah.
And so I think, I'm trying to do the science the way it should be done, by going to the site of the meteor, collecting materials, bringing them back, using the best instruments in the world in collaboration with two laboratories, one at Harvard University led by Stein Jacobson, a world-renowned geochemist, the other one led by Roald Tagel at the Bruker Corporation in Berlin, Germany. And then coming to the conclusions based on the analysis and trying to interpret those. That's the way I do my science. This is the way science is done.
Yeah.
If you look at all other questions that we are trying to address, for those people who are bothered by that, for those people who say we should not believe data that gives us trouble because we think about stones in the solar system and this object must have been like a stone from the solar system, I call that the Stone Age of science.
Right.
And they are lacking curiosity. They live in those echo chambers where they basically rely on past knowledge. And the way to gain new knowledge is to listen to nature. Let's see what this object is. Let's believe the US government, who went back to check the data and verified it. So, that was a full research team within the US Space Command. Why would you dispute it just because you want to promote the narrative that it was a stone from the solar system?
Yeah.
I mean, this to me is anti-science. These people are actually trying to argue that they're defending science. And they're ridiculing anything that goes against the models they have. But in fact, this is actually an anti-science approach, not to follow the routine of listening to nature rather than to listen to yourself.
I think that's the big narrative that I see in academia. It's more so the echo chamber narrative and the ivory tower narrative than jealousy narrative or things like that.
I should say kids are curious.
Yeah, I wanted to talk about that.
And I met with students in the elementary school where I went as a kid. Just a couple of months ago, I was visiting there, and I told the students as I entered, I said, look, I'm just like you. I wonder about the universe, about the world, and I try to figure it out. Okay. And one of the kids raised his hand and said, but Professor Loeb, we read about you. You are 61 years old. How can you be just like us? We are much younger. And I said, well, it's not a matter of biological age. And my biggest advice to those young kids is never pretend to be the adult in the room.
Yeah.
Because, that's what politics is about.
Yeah.
Very often you pretend to know more than you actually know. And we see the fallout from that. Very often, even the intelligence agencies provide government with the wrong advice. Because sometimes data is incomplete, the knowledge is incomplete. And if you are arrogant to show off, you would dismiss any uncertainty, you would follow what the echo chamber is saying. But if you're a kid, you would say, well, I'm not really sure about that. Let me check it out. And the other thing is not to be afraid of making mistakes. I spoke with the chief editor of Nature magazine just a few days ago, and Magdalena Skipper, and she basically said that one of the big problems right now in science is that whoever deviates from the beaten path is put at the town square and stoned.
100%.
And it shouldn't be like that because, very often, if you have incomplete data, incomplete knowledge, you might be making the wrong, conclusion.
Yeah.
And therefore, science is about iterating, responding to the knowledge that we have and correcting yourself. But if you always want to be right, you would either pretend to know more than you actually know or dismiss data that violates your prejudice because otherwise you would be proven wrong, or you would never take risks. And that's the worst that can happen in science.
Yeah.
If you're just curious and you say, okay, previously I thought this, but now I have data that shows me that. For example, in the case of the meteor, I was thinking maybe it's a Voyager-like meteor. Then I realized, actually what we found can be explained in a natural process. Maybe it's rocks from a planet different than the ones we find in the solar system. So I wrote a paper about it. There is nothing wrong with that because you're responding to what you know. And that's the process of learning in science. You learn from nature. You're not supposed to learn just from your colleagues because they have an opinion which is not always supported by data. And so there is a problem because science does not progress at the rate that it could progress if people were willing to take risks and make mistakes.
Yeah, that's something that I've noticed myself. And I feel like just because everything is so permanent these days, right? Like, I mean, you have kids, I have kids, like they live in a world where it's something that they said 3 years ago could be used against them, like, however many years. And so I feel like we need to have a cultural mind shift where people are willing to make mistakes and we're forgiving for those mistakes later on.
That's exactly the message from the chief editor of Nature. Yes.
Yeah. So coming back to just this idea of this type of research being, it was certainly less popular in the past. I think that if you were going in the vein of interstellar life, that you might have been on the fringes of the scientific community. And now someone like you, who's, very much, just like you said, a player in this whole thing, is able to take on these tasks and do this research. I guess my initial question was, do you feel like that consensus is changing, that it's much more acceptable now for these young postdocs like that you're training with to take on the research?
So in the Galileo project, I currently employ 3 postdocs from contributions made by foundations like the Brinson Foundation. Last week, we got a very big grant from the Richard King Mellon Foundation. We are getting support from very prestigious foundations and also from private donors. And 2 of the 3 postdocs told me that when I made them the offer that it was their lifelong dream to work on something like the Galileo project, but there was nothing out there. And they cherish this opportunity and they are really happy doing that and they want to continue it in the future. So, that's one part of it. But then there is the public discussing this subject. And I can tell you, I go places and there is a huge interest among people, and many of whom tell me that they follow the research because it really excites them. It inspires them. When I went to the expedition, I wrote 43 diary reports, put them on medium.com. That's where I put my essays every day or two. And there were millions of people around the world that followed my diary reports. And I got an email from Denmark from a person who said, I just had a stroke, and reading your diary reports gave me strength to live.
Yeah.
And what did he really mean? He meant that I was willing to put the time and effort and money to search for the materials of an object that the US government reported about that looks as if it's the first big object that we identified that came from outside the solar system that we can actually put our hands on. And, that is the way science should be done, driven by curiosity. And he found it amazing. And I find it common sense. There is nothing really special in everything I say. It's just that I get attention because most people don't say that. So why not make science exciting?
There's definitely a lot of bravery that goes into it. I would say. I think that you're being very humble. I think that there's a long history of people that may have been interested in this stuff and have been labeled as conspiracy theorists or kooks or things like that. But, you have virtue of tenure, you have virtue of the prestige of Harvard University. You've obviously, done the hard work. You've talked about the origins of stars and black holes and all this other stuff. So I think to have someone like you with the bona fides that you do, and the gravitas that you have it's inspiring to me, right? Like, and that's something that I think that would be such a huge event for humanity. And just like that gentleman that has had a stroke, it gives us all hope, right? Like, I only see upside. I know that there's a lot of people that think that first contact would be a negative experience, but I know you've talked in the past about how you think it's going to be a positive experience.
Yes.
How would you talk to those people that might be a little bit hesitant or pessimistic about first contact?
Well, indeed, I should say that my career gave me the safety, the tenure that I have to come out. But the most important part of my past is actually that I grew up on a farm and connected with nature more than with people. And that is the narrative that I follow. Pay attention. Keep your eyes on the ball, not on the audience, okay? Which sounds straightforward, but in the age of social media, you basically pay attention to the audience all the time. And, it's just like seashells on the beach. Each of them, usually when they're born, has unique colors, but after, they're there for a long time and the ocean waves rub them against each other a lot, they break up and become indistinguishable grains of sand. They lose their unique colors. And I say, rubbing against other people all the time, that's what takes away your unique colors. You have to maintain some independence. And that's what I'm trying to pursue. We live for such a short time. Let's make the most of it. I'm obviously losing opportunities for honors, awards, grants that I would get if I were to follow the beaten path. But that's not really my goal.
Know, man. If it pays off, that's a huge deal, right?
Well, yeah. And for that, it's a lot of work. And that's what I'm hoping for. But it's more about humanity.
Yeah,
and bringing us to a better place.
So anyway, coming back to the first contact thing, I know you've talked in the past about how optimistic you are,
right?
And I do feel like there's a lot of pessimism around this idea that once we make contact with an alien species, that we're going to be lower on the food chain and then potentially on the table, right?
So I don't see it that way. Stephen Hawking said it a decade ago that we should be quiet, that we should not transmit radio signals because they might come to haunt us eventually. There might be predators out there. And Well, first, I should say people shouldn't lose sleep on that, because the radio signals we sent out for over the past century only reached hundreds of stars by now. So the chance of them having a civilization that monitors the sky in the radio the way we do, and for them actually to travel to us, will take, many millions of years. So don't worry about it. But more broadly, I think going out to the street, I'm an optimist, because life is very often a self-fulfilling prophecy.
Mm-hmm.
If you don't search, you will not find anything. If you don't believe that you will find something good, nothing good will happen to you.
Mm-hmm.
And so I believe that we can actually benefit from the encounter rather than lose. We can learn from them, both in terms of technology and science. On the first encounter, I have two questions that I would like to ask. The first one is, what happened before the Big Bang? So we know the universe started at some point in time because we see it expanding. And Einstein's theory of gravity cannot really forecast what happened before then, because it breaks down. It doesn't have another pillar of modern physics, quantum mechanics, embedded in it to tell us what happened before that singularity. And if the aliens would answer this question, it will guide us how to unify quantum mechanics and gravity. That's one thing, but also it will deal with our cosmic roots, because there is a possibility that our universe, our baby universe, was created in the laboratory by some scientist who understood quantum gravity and could engineer a baby universe in the lab.
Mm-hmm.
And so I would like to find out what was our cosmic origin. And, it's possible that in our universe, once we figure out quantum gravity, we will create baby universes. And so it's babies inside babies inside babies, just like for humans.
Yeah.
That would solve the question of where did the universe come from.
Mm-hmm.
The second question I would like to ask is, where is the nearest hub where extraterrestrials come together so we can meet some and socialize with them?
Absolutely. No, I think that would be the most exciting feature for me. I think that, when I think about it, I think it's probably going to be a mundane experience. Like we might find bacteria on other planets. And
actually, a kid asked me that 2 days ago in Florida.
Mm-hmm.
And I agree that the microbes might be far more abundant.
Mm-hmm.
Okay. But they are not as interesting to me. Okay.
Oh, of course.
So, and also you might say, okay, well, we should invest tens of billions of dollars to search for molecules in the atmospheres of exoplanets around other stars.
Mm-hmm.
That would indicate microbial life, because that's probably the most abundant form of life. And that's exactly the mainstream view within astronomy right now.
Mm-hmm.
But that assumes that it's easier to find those molecular fingerprints
mm-hmm.
of the microbes in the form of oxygen, methane, carbon dioxide, other molecules. To me, it sounds like it's not clear that these would be the easiest signatures of life, because, for example, if there is a planet with a lot of industrial pollution, we could identify those molecules if there are city lights, very bright city lights
mm-hmm.
on the dark side of the planet. That would tell us that something unusual is going there.
Mm-hmm.
If we find a Voyager-like meteor at the bottom of the Pacific Ocean, that it could have buttons on it. And of course, the question would come up as we retrieve that gadget, whether to press a button.
Mm-hmm.
And I asked my students what to do, and half of the class said, please don't, it will affect all of us. Don't press any button. And the other half said, please do, because maybe it's ChatGPT 100.
Right.
We want to see what will happen. And then a student raised his hand and said, Professor Loeb, what would you actually do?
Mm-hmm.
And given the split vote, I said, no worries, I'll take it to a laboratory and examine it before engaging with it.
Mm-hmm.
But these examples of a gadget in the ocean, or city lights, or industrial pollution, or maybe even radio signals, they would not only potentially be far easier to detect, than microbial fingerprints, but we might find them first. Okay, and so investing all our funds the way that the mainstream in astronomy does right now in the search for the molecular fingerprints of microbes, I think is the wrong approach. We should split our chances between technological signatures and biological signatures. I actually wrote a book about life in the cosmos and describe both signatures. And I think we should hedge our bets. And it also relates to my advice to young scientists. There was a special celebration of my birthday a month ago at the Institute for Theory and Computation. Yeah. Thank you. And one of the students asked, what's your advice to students and postdocs at the beginning of their career? And I said, I have two advices. First, you want to diversify your portfolio. You want to explore risky ideas together with, mainstream, highly popular ideas. And the way to split it is, I suggested somewhere between 20 and 30% on risky ideas, and just like in financial investments. And then I said, well, later in your career, when you have tenure, you can change the balance and make, allocate more resources to the risky part. And that resembles what Pablo Picasso, as an artist, did, because he initially painted very realistically. And when he was asked why did he start his career painting realistically, he said he wanted to master that craft the way people practiced it before him. And when he demonstrated that, he ventured into Cubism, the abstract art that he pioneered. I think doing science can be similar. First, you want to demonstrate to your colleagues that you're able to reproduce the scientific work the way it's done, and then invent or venture into some new territories that are more risky, but are more creative and more fascinating. That's what I'm doing right now.
Absolutely. That's really salient advice. I mean, something that I could even say would be the same in medicine, like myself, I want to change gears here for just a second, because I would be remiss if I didn't ask you about us becoming a multiplanetary species, because I know that your basis is it's so much more broad than this one particular facet of astrophysics, right? I'm really hopeful for the new lunar mission, really hopeful that we might eventually go to Mars. What do you think that the future looks like for humanity as a spacefaring species?
Right. So first, I should say we should be careful about just going to the surface of Mars, because it's bombarded by energetic particles. And, within a few years, a human unprotected on the surface of Mars, would not survive because a significant fraction of the brain cells will be damaged by these cosmic rays. There is a simple solution, either to build infrastructure or to actually go into caves. We started from prehistoric caves on Earth, and we might end up in caves, in lava tubes on Mars. That's perfectly fine, because the rock can protect you from the energetic particles. It also protects you from the large variations in temperatures between day and night, which are hundreds of degrees on the equator of Mars. But if you go down, these are moderated by the layer of rock above you. I would actually want to explore some of these caves, because maybe there are prehistoric paintings on the walls of these caves on Mars, because Mars lost its atmosphere a couple of billion years ago, at the middle of its lifespan. And before that, it had liquid water on the surface. We know that because we see evidence for rivers and oceans, lakes. And so there could have been, life, there could have been intelligent life if it progressed twice as fast as on Earth. It's just a factor of 2 faster. And I want to find out if anything was left on the walls of those caves. We've never searched them. But altogether, I think it's very challenging for humans or any biological creatures from Earth to survive the long journey that it takes to reach other stars. And to me, it makes much more sense now that we have artificial intelligence to send gadgets that have a brain. We've never done that in space. We sent robots like Perseverance to the surface of Mars, but it's operated. This robot is operated by engineers in the Jet Propulsion Lab in Pasadena. We sent a helicopter to Mars, but it's also operated by those engineers. I call that helicopter parenting, where we are monitoring what happens to our gadgets and making sure that they do the right thing. And just like with kids, you don't want to helicopter parent. You want to let the kids explore on their own. And especially if they go large distances, they cannot report back and ask for advice. So you want them to have their own brain. And that means giving them autonomy. They don't need to report back. They don't need to ask for advice, just as with kids. And that means AI in space. Never done before, but we now have the technology and we could potentially equip spacecraft with a brain. And my guess is when we encounter functioning devices from other civilizations, it will probably not be biological the way we imagine it in science fiction. It will probably be with an AI brain. And then the question would arise, when we find a visitor in our backyard that is functional, it's really urgent to figure out what the visitor is seeking and what its intent is. And we cannot establish a committee ahead of time to decide about rules, because it really depends on the visitor. One time I saw a person on the street right where we are, looking at my home, and my wife said, "Go and speak with him. He's been looking for half an hour. Maybe it's one of your groupies." Or so I went there and I said, "Why are you looking at our home? What's going on?" And he said, "Well, I was born in this house. I lived there until 50 years ago." And I said, "Oh, great. If you want, have a look at our backyard." And so he said, "We buried a cat in the backyard named Tiger." And I said, "Well, that name sounds familiar, because I saw a tombstone with the name Tiger on it, and I was worried that the tiger is buried in my backyard." And he explained to me that it was a cat. And so what I learned from that is that you need to be kind to visitors, because they might teach you about ancient history before the time that you came to your home, because that territory used to be occupied by others before. And if we meet an alien or a gadget that is intelligent enough to tell us what was here before us, we will learn a lot. And so I see it as an opportunity to expand our perspective from now and here to the universe at large and a long time ago.
Even the technological innovation that it would come from seeing their technology, I feel like would be so beneficial for humanity, which is one thing that I did want to ask you about. I'm sure you've seen the congressional hearings about all these different UFOs and UAPs, whatever you want to call it these days. The one that's most striking to me is the Tic Tac video, right? The one that has multiple eyewitnesses of really great credentials, just like yourself, that can corroborate this information, both from a technical perspective and a visual perspective. That thing moves unlike anything that I've ever seen before. I'm sure that it probably made a lot of curiosity go off in your own brain. I'm not an astrophysicist. How would you explain something that moves like that?
We have very limited data, because the data was deleted or the government took possession, and we just don't have access, and we cannot really measure things there because it happened in the past. So I'm not clear about the origin of the only things I can think of are two things. One, perhaps drones that were tested at the time. There were new technologies that those people who saw them could not really associate them with something familiar. Okay, so that's one thing. The other possibility is that there were, light beams, just like a spot of a laser that a cat would chase around. That is not a real object, but it's actually, you produce something that the sensors detect, but is not real. But of course, there are two things that I don't have access to. One is the distance of these objects. I mean, when you see objects moving fast, it may be that they're closer than you think. And for that, to measure distance, you need triangulation. You need multiple sensors looking at the same object. Imagine going on a highway, seeing a black car behind you in your rear view mirror, okay? And then a few seconds later, you see the car in front of you, the black car, and you say, wow, it must have moved really fast. But in fact, it's a different black car. So if objects come into view and out of view, and there is a swarm of them, you might think they're moving really fast, but they're not the same object. Okay, so I would much rather prefer to have my own instruments with full data access to figure out what it is. It definitely raises my curiosity enough for us within the Galileo project to look at the sky. And, we have one observatory functioning at Harvard. We are building a new copy of it in Colorado. And we just got funded by the Mellon Foundation to build a third observatory. So we'll have ultimately, within a year or so, 3 observatories looking at the entire sky in 3 locations all the time. And
Harvard, Colorado, where's the third one going to be?
It will be in Pennsylvania.
Okay.
And then we will get possibly millions of objects that we monitor over a period of a few months. And, we can check if any of them is anomalous, rather than people who report about an object because they happen to be at the right place at the right time. If you hear such reports, you just don't know how frequent are such things. And when you observe the sky all the time, you have the background. And so that's extremely important, going away from anecdotal reports to statistical inferences. The other thing is, I was at visiting CERN and to give a public lecture, and I had there was a special dinner hosted by the organizers of the event, and some very distinguished people were there, including very wealthy people. And 2 of them approached me and said, about 2 decades ago, I witnessed something extremely unusual. There was this huge object and it moved really fast. And then there were some fighter jets chasing it, and it moved much faster than they could move, or things like that. And I heard it from a number of people. And these are serious people. And so you wonder if there is something out there that is behaving very differently than familiar objects. Perhaps it is military, perhaps it's technologies being tested, but why don't we just watch the sky and figure it out ourselves? That's what we are doing with the 3 observatories.
So that's a very scientific way of looking at it, and I really appreciate that, because that's who you are, right? To your core. I'm sure
By the way, my wife says that I'm scientific also when I think about people, and she laughs at that. Like a few days ago, I made salad in the morning, and I was using a knife to cut the tomato, and then I thought to myself, why is the knife cutting the tomato? And I realized, I put some force on the handle of the knife, and this, because it's a rigid body, transmits the force to a very small area at the edge of the knife. And the force per unit area exceeds the material strength of the skin of the tomato, and that breaks the skin and it goes through. And obviously in medicine you're familiar with that. But the poet Rilke said, he said, in life we have a lot of questions, but you can't find answers to those questions most of the time, and therefore you can hope to find questions eventually that have an answer, but otherwise you should just live your questions. And that sounds very romantic. A lot of people live their questions. You just go through life with the questions unsolved. And I completely disagree with him. As a scientist, I completely disagree. I say we need to try and answer the questions for which we have no answers. Obviously, what we know is an island in an ocean of ignorance, but let's do our best. There is a question that bothers you. Some people talk about objects in the sky. They don't understand. Let's just figure it out.
Yeah. No, I appreciate that. But I also know enough about you that you had a background in philosophy.
Right.
And, if we were to just philosophize and conjecturize, how is an object able to move without any sort of propulsion? As someone who's not.
So let me give you an example of something really exotic.
Yeah.
The most exotic I can think about.
Yeah.
So about 70 years ago, a physicist, Hermann Bondi, a very distinguished physicist at the University of Cambridge, wrote a paper about the possibility of a negative mass in Einstein's theory of general relativity. And the idea is that, in electromagnetism, we have positive charges and negative charges. In the context of gravity, we're only familiar with positive masses, and that's why gravity is attractive. But imagine the possibility that there was a negative mass, it will be repulsive. Okay, so it will generate repulsive gravity. And he said, that's not in conflict. It's just that we don't see any of that. And so now imagine placing near Earth another planet like the Earth, but with a negative mass. Okay, so it will exert, this negative mass will push the Earth with 1g, the same gravitational acceleration we feel on the surface of Earth. So it will push it if it's close to it. And the Earth would attract this negative mass with 1g. Okay, so actually they would move together. And they will keep accelerating at 1g because the negative mass keeps pushing the Earth and the Earth keeps pulling it at exactly the same force. And what you will get is a system that accelerates indefinitely up to the speed of light and beyond, and as close as possible to the speed of light. We can't go beyond the speed of light because that's the ultimate limit. But if you accelerate at 1g for 25 years or so, you will get so close to the speed of light that time will propagate so slowly in your spaceship, on this planet, that in fact you will age by 25 years, but you will cross the entire universe, billions of light years during that time. So for the Earth, if you come back to Earth during this journey after a billion years, you'll see the Earth the way it looks a billion years from now, even though you aged maybe by 10 years at that time. So that's an example for a propulsion system that needs no fuel. There is no exhaust, no rocket. It's just gravity that does it. If we only found the secret of how to make an object with a negative mass, and I'm working on such a paper because we know that, for example, the universe as a whole is accelerating its expansion. And so there is an example for repulsive gravity in reality, except that it's the vacuum that does it, and the vacuum is uniform. It's everywhere. So this negative gravity is applied to everything in the universe, and that's why we are accelerating relative to other galaxies. But if we could bottle that vacuum energy in a confined vessel, then we might be able to get negative mass. So this is just to give an example for how our imagination is limited in the context of gravity with just attractive gravity. And it could be that, if you bottle the dark energy that makes the universe accelerate, perhaps you can create a propulsion system that needs no fuel. Okay, and there are other possibilities. You could, if you have enough antimatter, you can use it as very efficient fuel, because when you combine matter with antimatter, you get the entire energy out from the rest mass of the fuel that you have. So that's the highest efficiency fuel that you can imagine.
Yeah. So I feel like as someone who's in the field, a player, like you said, you have access to all of the different hypotheses and opinions that I don't have, right? Like I don't know what the cutting edge on astrophysics is. Is there any possibility of this coming from what we know right now?
Yeah, so for just to give you another example, most of the matter in the universe is called dark matter.
Mm-hmm.
It's invisible. It contains 83% of the matter content of the universe. And we don't know what it is. We've never seen it in the solar system. It's a substance that is not familiar to us. And, there are billions of dollars invested in laboratories to search for the dark matter. In fact, the Large Hadron Collider smashed particles at very high energies to see if the dark matter particles are produced. And it didn't find the dark matter. Didn't find the symmetry of nature that it was hoping to find, supersymmetry. So we still don't know what the dark matter is. It was discovered about 90 years ago. And so in principle, for example, if the dark matter can be engineered, suppose we figured it out and we were using it as fuel, just imagine that it's useful, then because it's invisible, we wouldn't notice it as rocket exhaust gas coming out of a vehicle. So this is an example. I mean, I don't know what the dark matter is. Maybe it can be used for engineering purposes for travel. The same about dark energies we just talked about. It could be bottled. If it could be bottled up, that substance that causes the universe to accelerate, maybe you can use it for propulsion. These are two examples of things we know about that we don't understand. And
that's what I think is more important to me, is the fact that there's no understanding of it right now from the terrestrial perspective.
Right.
Because I think one of the reasons why I'm asking you this is because there's conjecture that it might be terrestrial technology from another country or, some other state actor that we probably don't know of. And, I think that I find it, as just a layperson, a huge technological leap that we don't have understanding of. Is that consistent with the cutting edge that is available to you? Like there's no way that with our current basis of technology, even in the circles that you run with, that we could develop something like this?
Right now, no.
Okay.
I mean, the point is that we have only 1 century of science and technology. We're pretty early in the game, and we already see technologies that are growing exponentially. That includes artificial intelligence, because it started with Moore's law that was exponential, and the capabilities of chips in computers growing exponentially that led to the internet, now to artificial intelligence. And, all of these exponentials will eventually reach some saturation point where, there's something that limits their growth. We haven't reached that yet. And we are still in the first century of those technologies. So that tells you that if you just wait for another century, these technologies will saturate at a level that we cannot imagine, that they will transform our society.
Oh, yeah.
Artificial intelligence, might become smarter than us. And the reason I say that is because ChatGPT, for example, just a few months ago was argued to as a result of its interaction with people, it became dumber. Some people said, well, it used to be much smarter. And to me, it's an indication that, it's getting there. It's getting to be smarter than us. And definitely, if we wait a decade, it will be smarter than us. And that will lead to some people viewing it as an oracle, as as a genius, because you can ask questions that humans cannot resolve, and this AI system will solve those questions. And that will demonstrate to us that we are not the pinnacle of creation, the way we are often insisting that we are now the smartest on earth. But in fact, that may not be true with our technological kids. I have no problem with that, because I have 2 daughters, and when they do better than me, I'm actually happy.
Yeah, me too.
I don't see that as a competition. And moreover, it will show us that if on earth we are not the smartest, somewhere else there might be someone even better than our AI systems. And our AI systems will benefit from an interaction with an extraterrestrial AI system, because they would try to imitate that AI system the way that the imitation game was thought about by 90 years ago by Alan Turing. So altogether, it's a way for us to grow, having those technologies. And if we can only admit that we are not at the center of the universe, both in terms, we already admit that the church, the Vatican, admitted that Galileo was right 30 years ago. It took them a while. The humans already landed on the moon by then. But the other revolution that is really awaiting us is that we are not the smartest, right? And that's actually to our benefit, because we can become smarter by interacting with things that are smarter than us, like AI that we created, and like extraterrestrials that have nothing to do with us. And so I'm really looking forward to that because, when reading the newspapers every day, I get depressed, frankly. We're not, we're investing $4 trillion a year on military budgets, and we better use those resources to work together instead of killing each other, to actually explore space. I calculated that we could send a CubeSat towards every star in the Milky Way galaxy within 1 century if we were to allocate $4 trillion a year.
Interesting. Honestly, I think that there is a lot of negative media attention, because I think that is the business of media, is the outrage machine, right? And so
but
it's nice to hear things like that, which is giving a sense of optimism and hope. And like the fact that we would be able to do something like that is just truly fascinating, because $4 trillion to me seems like a drop in the bucket compared to the world GDP, right? It's not something that's unattainable.
No, I mean, we are spending it on killing each other, which is the wrong thing. There is an Orthodox Jewish community in Brooklyn that believes that the Messiah will come from within, from Brooklyn. And my view is that it's more likely to come from outer space, from another star. And the reason I say that is because perhaps peace will come to Earth, which is the messianic message. And, when we interact with a more intelligent species, with either the AI of the future that we develop or an extraterrestrial AI, there would be a sense of awe, which is sort of like a religious feeling. You would witness a miracle, something that you've never seen before.
Exactly. It expands your concept of what is possible.
Exactly. I mean, if you think about the religious experience of Moses in the Old Testament, Moses saw a burning bush that was never consumed. And that experience convinced Moses that God exists. And today, I mean, you could fool a person like Moses easily by buying something off Amazon that looks like a burning bush and is never consumed. And so if I was next to Moses, I could use the infrared cameras we have in the Galileo project to tell Moses the surface temperature of this burning bush and the composition and the amount of power emitted by it, and advise Moses whether this object is indeed artificial and was manufactured by a superhuman intelligence. And that's something we can do with the help of science. And we might use the same tools to figure out a superhuman intelligence, but it would be real. It will not be a religious belief system. It will be based on scientific evidence. But the sense of awe would resemble religion. So to me, it brings an opportunity to unify religion with science.
Yeah, I have to put a caveat on that, because there was a recent, and I don't know if it just, the algorithm was just giving me a ton of information about you because I was interviewing you, but there was a recent article that said, Dr. Avi Loeb thinks the Messiah will come from outer space. And it was almost like attempting to discredit you, which I just want to reiterate the fact that I know that you're being tongue in cheek about this. I know that you're hoping for the best for humanity, and you hope that it will come from outside. Correct?
Yeah, because I don't see humanity correcting course. I mean, the war in Ukraine is not very different than the wars that used to happen last century. Okay, and the question is, when will we learn that we should come together and work together? And to me, the sight of a neighbor defines your family. Okay, when you live in a house and you're not aware of anyone living outside the house, you get into fights within the family. That's a natural tendency. But once you see a visit, someone knocks on your door, and you realize that you have neighbors,
100%.
you change your behavior, right? And this is really my hope. And to me, it sounds very reasonable that, you know, if we search, we might find something. Obviously, if you have a strong opinion and you want to believe that we are unique and special, there is nothing like us, and therefore we don't have neighbors, you know, you will not find them.
Yeah, no, I totally agree. You know, my true love is science fiction, and a lot of science fiction talks about this, is that as soon as we find out that we're not the biggest predator in the pyramid, then all of a sudden everybody is, you know, very, very happy with each other, and all the wars stop. And I really truly believe that that's something that's going to happen. I think that, you know, for whatever reason, having a commonality of just our species versus another species, whether it's right or wrong, is something that's going to be a benefit for humanity. But
well, you know, every day I have this routine. I go to the mailbox that is just next to us and check if I have anything there. You know, and why shouldn't we do the same in the context of the solar system? Check if we have anything in our backyard that is different from rocks, and that would inform us about something more advanced than we are, that we can learn from and that we can aspire to be.
Absolutely.
And that's more than just becoming a multi-planet species. And planets are not necessarily the best habitats. You might be able to create an even better habitat on a spaceship if you equip it with a nuclear reactor and other things. Why? I mean, we are enjoying life near the sun just because it's a nuclear reactor that gives us the energy we need for life. If we are not too close to it to be burned up, or too far from it to freeze. But in principle, you can, you know, this is what nature gave us by chance, but we can design a habitat that will be better for us. And we already are doing that with technology. You know, I'm sure the brain of Gen Z is quite differently wired than the brain of previous generations. Absolutely. Because they were exposed to cell phones throughout their life. And if you interact with an electronic display, your brain gets rewired differently. And so the interaction with technology will not only change our environment, will change us. And you know, the way I see it in the distant future is that we will leave this rock. And if I'm offered, if a spaceship lands in my backyard and they give me an opportunity to ride with them, and even if it's just a one-way trip, I would take it because I'm just curious to find out.
How does your wife feel about that?
Okay, so 10 years ago, she said, please go ahead and just make sure that you leave the car keys with me. And please ask them not to ruin the loan when they take off. But actually, I asked her again because my statement appeared in the Boston Globe just a few months ago about this. And then, so I asked her, what's your take right now? And she said, I would actually join you. And well, it shows two things. One, that, you know, we have a good marriage. And second, you know, it shows that world affairs are frustrating her. Okay? And she's not happy with how things are going here on Earth. And for me, it would be great to have her as a company. And, you know, I asked my students again, I said, if you have the opportunity to take a ride, would you do it? And they said, as long as we can still use social media and especially Instagram to transmit photos back to our friends. And I said, why would you have that need? I mean, can't you just enjoy the trip?
It's because they're rewired differently, you know, that they get that dopamine fix from the likes. So, you know, last question before I get into the three questions that I ask all my guests, because we are getting close to the time, and I want to be respectful of your time as well. The Galileo project has been going on for a little bit of time now. Is there anything that's coming down the pipeline that gives you some hope or optimism that that might be revolutionary for us?
Yeah, so two things. One, we will soon have more than one observatory. Hopefully, we'll have three of them within a year, hopefully. And that will give us much more data. We'll have better machine learning software analyzing it. And, if there is something in the sky that is from outside of this Earth, we hope to find it. Okay, so it will not be a hypothetical question anymore. It will be a question of data analysis. Okay, and we will, of course, let the public know if we find something. And the second thing I hope to accomplish in the coming year is plan the next expedition to retrieve bigger pieces of the meteor that we discussed. Because if you find a bigger piece, you can actually tell whether it's a rock or a gadget. You can also find elements that were vaporized by the explosion. So if you have just the tiny droplets that we found, less than a millimeter in size, many of these volatile elements were lost in the explosion. And if we find bigger pieces, they would still be there. So we will know the composition better. But even more importantly, we could, with large enough samples, we can actually analyze isotopes of radioactive elements that act as clocks because they disappear after some time. And if we can analyze those clocks of radioactive decays, we will be able to tell the age of the material that made the object. And that could inform us about the duration of the trip, the journey that it made, and the distance that it traveled. Wow. Because we know the velocity that it went.
Triangulate where it's coming from.
Yeah, so we potentially. But this is all for the future if we find bigger pieces. And we are now planning the expedition. It will cost about $5 million because we need better equipment to find the bigger pieces, including a remotely operated vehicle and the video feed from the ocean floor. So first thing is to find a funder that would, we will be happy if the funder joins us on this trip. We have several options for a ship, and we're starting to design the equipment. And so hopefully that will take place within the coming year. And stay tuned because it will be more exciting than the previous expedition.
Yeah, that's pretty interesting. I hope that somebody that's out there watching this will see what Dr. Loeb has planned and will give you the funding that you need to answer those really important questions. Thank you so much for doing this. I always end my conversations with three really general questions just to see what people are thinking about in really general terms when it comes to the future. I take a different tack than you. I know that the humanity looks a little bit bleak right now, but I feel like, I see people like you that are doing these amazing things, and I'm hopefully optimistic about the future. I really look forward to a time where I have a robot butler that can mow my lawn for me, that can do my laundry for me, the artificial intelligence that I'm able to talk to and set up all my podcast gear without having to, do it myself. But I think most importantly is that, I see people like you, that are being brave and doing things that are really interesting and trying to push humanity forward. What do you gain inspiration from? Because I know that that's something that you've talked a little bit about in this talk, which is just the hope that you have for the future. Where do you find your inspiration?
My inspiration is from young people. I really am fascinated by youth because it brings two things. One, a sense of curiosity. The young people are, they are like those colorful seashells that you find on the beach. They are not, eroded yet by the difficulties of life. And so they're interesting. They are inventive. They are not sabotaged as much by tradition, and so that's one aspect of young people. And the second is, of course, their sense of curiosity and the fact that they're not so attached yet to their ego. And I was always fascinated by young people, and I still try to maintain my childlike curiosity. And so that gives me inspiration the most. And anything to do with creativity, you know, music, art. For example, in terms of music, I always enjoy the music of the day. I don't reminisce about the Beatles. I don't really.
What are you listening to right now?
Well, for example, what's you will cut this, but what's her name? Not Ashley. This
Taylor Swift?
No.
Ariana Grande?
No. The other
Adele?
one. No. The one that has strange colored hair. She's 20 or so.
Oh,
what's her name? What she had a song. What was I made for? We can check it on. Do you have?
Who sings the song? What was I made for? No. Who sings the song, quotation mark, what was I made for?
I found this on the web.
Billie Eilish.
Billie Eilish. Yes,
Yeah.
so we can get
Okay, yeah. So what are you listening to right now?
Well, for example, I loved the song of Billie Eilish, What Was I Made For? Because it resonated with the question that you asked.
Yeah.
And my answer to this question, what was I made for, is to find a partner in interstellar space. Because we know from our personal lives that finding a partner changes your life. It changes your objectives, the way you think, the way you act. And so I see it in a romantic perspective as a life-transforming encounter. And I'm seeking that partner. And if I find it, that's what I was made for.
Yeah, that's profound. That's really great. No, I really appreciate that. And then also kudos to you for being up on Billie Eilish. I can't say that I'm as up as you are. So that's pretty awesome. So next question that I ask all my guests is, where do you see us in 10 years? You know, like we have a lot of great things, especially from the astrophysics and space perspective. We have the moon landing coming up, hopefully. We have a lot of new countries that are getting into space. We have all of these new breakthroughs that are happening from the Galileo project and things like that. But where do you see us in 10 years?
So on that note, I should mention that we established, together with Frank Laukin, a colleague of mine, a new corporation that aims to send swarms of small probes to Mars, the moon, and the goal is to search for life on Mars, for example. But it's a different approach where small gadgets, a lot of them, could do much better job than the traditional approach of sending one big spacecraft. And so I see that as the wave of the future, because it offers the advantage of visiting many sites at the same time and diversifying your chances of finding something exciting. And one thing I'm really hopeful is that one of these probes will be a drone that would get into caves, lava tubes on Mars, and check for any prehistoric paintings on the walls.
I hope so. I hope that we have that experience of finding something else that kind of makes our whole frame shift. I think that would be a huge event for humanity. And honestly, if the past 5 years have been any indication, like we're increasing exponentially in both like our understanding and honestly tolerance of this kind of research. And I really hope that happens within the next 10 years. I think it will be really awesome for humanity. So last question. We talked a little bit about all sorts of different technology. Aside from astrophysics, what is on the cutting edge? Like when you're reading the paper, you just can't get enough of. What interests you from the technological breakthroughs that are happening? I mean, we have advancements in longevity, artificial intelligence, self-driving cars, robots. What are you really excited about?
Artificial intelligence, because I think it will transform humanity. It will make us smarter, but we need to adapt to it. And for example, in philosophy departments, they often teach ancient Greek philosophy. This is what the ancient Greeks thought about, but they didn't have computers, they didn't have AI. And as much as we can learn from their wise thoughts, I think philosophy departments, or the humanities more broadly, should engage in the future rather than the past. And right now they are suffering from a low level of interest from incoming students compared to technology. But if they engage with how to adapt to the new technologies that come along,
Absolutely.
they would be humanities of the future. For example, there are ethical issues related to AI. Well, first, how to protect privacy, but also, how to avoid the AI systems from getting out of line with the legal system that we have, and how to, for example, change the education system. The education system had to respond to the invention of the calculators, but those large language models are much more transformative. And right now, students are composing their essays using ChatGPT, for example. And so we need to adapt to that. And there is a lot of work to be done, both on the legislative front in Washington, D.C., about if, for example, an AI system triggers damage, who should be blamed for it? Is it the manufacturer? Or if the AI system evolved by itself, should we regard it as independent of the manufacturer, just the way we regard kids that left their homes as liable for legal suit because they become adults after a while? So there are all kinds of questions like that I think need to be addressed. And there is a room for both the psychologists and philosophers in resolving the challenges. By the way, if we ever discover an extraterrestrial AI system in our backyard, I would not consult physicists as to how to respond, because physicists are dealing with atoms, light, molecule, elementary particles that follow deterministic rules and are not thinking. Whereas psychologists focus on intelligent systems, humans, and they would be better equipped to dealing with intelligent systems coming from extraterrestrial origin. Intelligence requires you not to give up on your sense of control. And so when people say we are very afraid of the future with AI, we should stop research, for example, for 6 months. That suggestion was made. The only thing that came to my mind when I heard about it is that these people who advocate that are probably not good parents. Because as a parent, you get used to the fact that you cannot control intelligent beings. You have to influence them. You have to educate them, in the sense that AI systems should be trained on data sets that would bring them to the place where we want them to be. You don't take your child to a dark corner in the street so that they see all the crimes made there. You want to monitor what they absorb from the environment. That's called education. And the same is true about training AI systems. And therefore, instead of being fearful of AI systems causing damage, you should basically try to make them accept your guiding principles. This is exactly what you do with kids at a young age. And, if you were to adopt this approach and say we should have no children because they are not under our control, they are intelligent beings that operate independently of us, that would be devastating. So I think for the future, we should definitely encourage new technologies that will create a new world, but we should adapt to them in an intelligent way, the way we adapt it to other people, the way we adapt to our kids, the way we adapt to any other risk in the future, and try to make the best of it, rather than worry and suppress advances in that direction.
Yeah, no, I agree with a lot of what you said. I think that technology in general is like a tool, and it can be used for either good or bad.
Exactly.
And we have to be humble enough to know that it's not always necessarily in our control, and provide the best avenue and best environment for it to be of benefit to humanity.
Exactly.
And that's not going to happen without the humanities. I think that we're seeing a lot of the results of that is just the overwhelming progress without any direction from humanities, whether it's like the negative effects of social media or, what have you.
Exactly.
So I really hope that we have a lot more influence from people that have a ethical and moral basis to guide humanity into the future. And I honestly think that that's going to happen. I think now it's just we're catching up. There was just so much progress.
It's because of these exponentials.
Yeah.
We are used to slow progress, which
Right.
is true of an exponential early on, that it doesn't get to a threatening level, but towards the saturation point of the exponential, things get really hairy, and you need to respond to them fast. And so we are catching up, as you say.
Yeah. The only thing that I disagree with is I do want a physicist, the one that's sitting across from me, to be the one that talks to aliens the first, because I think that I've learned a lot from today's talk. Everything from the interstellar stuff all the way to humanity's role in space, and about being a good parent, about being a good husband. So I really appreciate our talk today. So I do hope that you're the guy that we're first having that first contact with. So thank you so much for having us. I really appreciate also to our listeners and to our viewers for experiencing this conversation with Dr. Loeb. Please help him out as best you can. I think he's doing really important work, especially if there's somebody that's out there that's going to fund him. I think that would be really helpful. But please also like and subscribe to the Futurist Society if you like optimistic views about the future, so that we can all build a better future together. So thanks again to you, Dr. Loeb. Thanks again to our audience. And for everybody who sees us on a regular basis, I will see you again in the future. Thanks, everybody.
We appreciate you taking part in today's episode. Take this chance to reimagine a better future by joining a community of futurists who strive for a remarkable world. Be a part of this growing network and contribute to making the world a more positive place. Visit thefuturistsociety.net and subscribe to the show so you don't miss a drop of hopeful futurism.